All right, we're back to our lesson 1.2. We're talking about the pH scale now in a little bit more detail and doing some calculations around pH. So our pH scale lets us figure out the acidity or how much hydronium ion is actually present. So that's what the pH scale is actually talking about. How much hydronium ion is there present in that solution? So when you see these little square brackets, that actually means concentration of whatever's inside. Concentration. So when I see that, I read that as hydronium ion concentration, just that. Okay, so that hydronium ion concentration can be used to approximate the pH. Just a little side here before we go on too further. Remember, if something is neutral, it means that you have equal concentrations of the hydronium and the hydroxide ions in solution. Okay. All right, now this chart over here is just like a really interesting one. Nothing you have to memorize. It's just interesting to see what the pH of different foods are. Ooh, Brussels sprouts, 8.0. That's on the base side for sure. Let's find, oh, honey is on the acidic side. So just kind of see how the different kinds of foods are acidic or basic. All right, so just taking a quick look at the pH scale again. Remember, between higher than 7 up to 14, these are our bases. So these are our strongest bases will be found up higher. If your solution is basic, that means you have a higher hydronium ion concentration than you do. Oh, I said it wrong. A higher hydroxide. These are hydroxide. Higher than the hydronium ions for a base. If it's an acid, then you're going to have higher hydronium ions and a lot less hydroxide ions. If you're neutral, the ions concentrations are equal. All right, now, because our hydronium ion concentration changes by a factor of 10 each step in the pH scale, this is known as a logarithmic relationship. All right, now, here is this relationship explained. So every time you go from like a pH, so this is pH along the bottom here, of 1, so you increase by 1 in pH, it actually changes the concentration of the hydronium ion by 10 times. Okay, so you'd multiply the concentration by 10. So every single step in that pH scale means the next one is 10 times more or less concentrated than has more or less hydronium ion concentration, 10 times. Okay, so if you're going up 2 steps in pH, so say from pH of 6 to a pH of 8, or vice versa, the concentrations are going to differ by 100 times. Now, let's think about this. Which way is the hydronium ion concentration going to increase? Hydronium ion directly relates to the pH of an acid, right? It gives you the pH of an acid. Actually, it gives you pH of everything, but it gets bigger, higher for acids. Okay? So if you're going down the scale this way, then your hydronium ion is going to increase more this way. Okay, so if you're going from a pH of 8 to a pH of 6, so say we're going this way now, pH of 8 to pH of 6, that means your concentration of the hydronium ion is going to be 100 times bigger. All right, so let's take a look at the formulas for pH and hydronium ion concentration. So if we know the pH and we want to find the hydronium ion concentration, we can use this formula here. Now, this is in your data booklet on page 11. So this is to find the hydronium ion concentration. We don't know it, but we're given a pH. So maybe the pH is 7, whatever it is. You would plug that 7 in for the pH. So it's 10 to the negative 7. So this is an exponent here. There's no units with pH, so you don't have to put any units into this formula, but you do need to remember that concentration for hydronium ions will be in moles per liter. Now our other formula on the other side here, also on page 11 of your data booklet, will help you find the pH if you know the hydronium ion concentration. So if you're given the concentration in moles per liter, then let's say it's like 3.0 moles per liter, you can put that in for your hydronium ion concentration, and you're going to use the logarithmic function on your calculator and take the negative of the answer. So negative log base 10 times your hydronium ion concentration will give you the pH. All right, so now when you find that pH, you do not need any units in your answer. Now there are some significant digit rules around this. So just watch it. It's really a little bit different. So for pH, your significant digits are only the digits that are after the decimal. Okay, so in this number here, of this pH 5.31, there are only 2 significant digits in that number. So that means your concentration that you find can only have 2 significant digits. So 5.0, that is 2 significant digits because you've written that 0. Okay, so just watch that. pH, you only count the numbers after the decimal as significant. So let's try a few examples. Here's the first example is you're given the pH of 5.72 and you want to find the hydronium ion concentration. So here's your equation you're going to use with hydronium ion concentration is equal to 10 to the negative pH. You're going to swap out the pH for the actual value of the pH that you're given. And remember in the formula, it's negative pH. So that 5.7 is now negative 5.7 in your formula. So watch out for that. Now, you can see if this is the kind of calculator you have, great. This will help you visualize this. You're going to put 10 to the exponent negative 5.72, and this is your answer. Remember, we don't write e negative 6. That is the same thing as saying, well, we rounded it off. So it's 1.9 because, why is it 1.9? This pH has only 2 significant digits. There are only 2 digits after the decimal, so only 7 and 2 are significant. So your answer can only have 2. So that's why it's rounded to 1.9. Okay, so we rounded it to 1.9. And then the E, so we forget about all this stuff. The E is the times 10. So E means times 10. And to the negative 6, that's your exponent. So our concentration of hydronium is equal to 1.9 times 10 to the negative 6 moles per liter. All right. All right. Try that in your calculator. If you don't get that answer, you need to get some help with your calculator just to figure out what the keys are to getting this in. This next question is going the other way around. You're given the concentration of the hydronium ion, and you need to find the pH. So you're going to use the second formula. It's in your data booklet, so you don't have to memorize it. You just need to know where to look for it. Your pH is equal to the negative log base 10 of the hydronium ion. So here's our hydronium ion concentration. We're going to put that in for hydronium ion. So in the calculator, it's going to look like this. Negative, you do need to put the negative in, log, bracket, 2.27, and then you don't hit the times 10. You can just get your EE button. It's either E, or on some calculators, it might be EXP, or on my calculator, it's double E, like EE. And that E does the times and the 10 for you. So you don't need to put it in. And then you just put in negative 7. Hit your enter button, and this is your answer. This is your pH. Now, how many significant digits are we going to need? Well, we go back to our initial question, and we see 2.27 times 10 to the negative 7. This is a concentration, so all of these numbers count as significant. So 2.27, that's 3 significant digits. So if we want to have 3 significant digits in a pH, that means we need 3 decimal places. So that's where our 3 decimal places gives us 3 significant digits. The next number is a 9, so we need to round up our 3. So 6.644 is our pH. Remember, pH has no units. All right, I have included 2 more videos of each of these different kinds of calculations, totally different calculations, and you'll see it's using a different type of calculator as well. So a lot of you may have a scientific calculator like this instead of a graphing calculator like on the last page. Watch these videos, even if it's not your calculator. Watch them and see if you can get the right answers on your calculator. All right, as we mentioned before, there's other ways to find pH. So we talked about the litmus paper. It gives you a rough idea, pH meters, universal indicators. So these are indicators like something like this. It gives you a gradient. Like you can use it and then compare it and get an idea of, is it a base, acid, and then what pH range it might be at. And then there's also acid-base indicators, which we're going to take a closer look now. And these are substances that when you put them into an acid or base, or an acid or base into them, they're going to change color depending on the pH. Yeah, they're very handy. So you actually have a data table of acid-base indicators on page 12 in your data booklet. And so you're going to need to know how to use these to predict the pH of an unknown solution. So let's just take a look. Here's a part of your page 12 that was taken from your data booklet. And we're looking at the methyl red indicator in this case. So methyl red will change at a pH of 4.8. Okay, so you get a pH range given to you and you have the color change. Okay, so and you'll see it goes red to yellow, 4.8 to 6.0. So this tells me that 4.8 and below is going to be red. I'm going to use a red pen just to really emphasize this. So below 4.8, this solution of methyl red, the indicator, will be red. Above 6.0, you can see that above 6.0 pH and above is yellow. Ooh, and I'm writing yellow, hard to see it. Okay, so this indicator, if you put it into an acid that is below 4.8, so like 1.2, the indicator, methyl red, will be red. If you put this into a base like that is like, say, pH of 9, the indicator will turn yellow. Now, what happens if you have something in the middle of these colors? Well, you guessing it from what color I'm picking. So if you have, say, a pH of 5, so anywhere in between there, so 5.9, 5.5, you're going to have a mixture of the red and the yellow. So this would be orange. So any pH in between 4.8 and 6.0 will come across as orange. So this is how we can use indicators to solve some problems. All right, so we're here given some information and we're going to use our data booklet to see if we can solve this problem. So bromophenol blue, it says we have a solution with an unknown pH is tested with these 3 different indicators below and the results are shown. So bromophenol blue is blue. So let's find bromophenol blue. There's bromophenol blue indicator. And it is blue. So it is indicating this. So what does that tell us about the pH? Well, this indicator says it's blue when it's 7.6 or above. So I know that our pH has to be greater than 7.6. So I'm going to write it like this, 7.6 or above. Okay, so we also took the same unknown solution and tested with phenolphthalein. So let's find phenolphthalein. There's phenolphthalein. Phenolphthalein is colorless in the test. There's colorless. All right, it changes from colorless to pink from 8.2 to 10. So if it's colorless, then it must be less than 8.2. got to be less than 8.2. All right, well, let's look at the last bit of data that we're given. Phenol red. Phenol red, where are you? There you are. Oh, you're all right beside each other. Phenol red, and it is red. So here it's at the top end of the scale. So it's above 8.0. So it's got to be on this side of 8.0. All right, so we look at all of these pieces of information. We have to estimate the pH of the solution. All right, so I know now that we're higher than 7.6. The pH is higher than 8, but it's got to be lower than 8.2. So our pH must be between 8.0 to 8.2 range. So using a bunch of different indicators lets you play around and kind of figure out what the approximate pH of an unknown solution might be. Oh, and there's just our answer. And walking you through the steps there. Alrighty, so if thymol, again, we're going to look at another indicator here. Okay, if thymol blue is placed in a solution with a pH of 1.5, the color will turn orange because it is right in the middle of the range, right? So you have a mixture of the red and the yellow. What color would alizarin be when it's placed in? Where's alizarin? Oh, it's yellow to red too. But what about like this one? This is more interesting. Here, thymol blue. Say you have a pH of a solution that is 8.5. So right there in the middle. What color will thymol blue be in an 8.5 solution? The pH. It's going to be the combo of yellow and blue. What do yellow and blue make? Hopefully you're like green. Yeah, green. So you need to know a little bit of your primary colors to do a little color mixing here. All right, and I believe that was the final slide of the lesson. All right, that's your part B. Make sure you go try some of these indicator questions and your pH to hydronium ions.